Okay, so we talked about, in chapter 23, we talked about random variables and expectation and variance. And the idea with the random variables that individual outcomes are connected to probabilities. So the question is, what kind of problems would generate this? So here's a question, here's a problem. Imagine you're on vacation for 7 days, and there's the probability of rain is 23%. And so the question, sorry, I keep running out of ink. So the question is, what is the probability that it will rain exactly 2 days? So what it finds, the probability it will rain exactly 2 days. So why is this a binomial distribution? Well, there's 4 things. First of all, there's what we're going to call n, which is a fixed, like a number of events. Or like trials, right? The next thing we're going to look at is this exactly 2 days. When I first learned it, when I started teaching it, they used the letter R, some use K, Cambridge uses X. So let's use X. And this is the number of successes. Okay. The third thing is that the probability of rain is 23%. So there's either, the probability of success. Okay, and that means, the probability of success. In a binomial distribution, there's only 2 outcomes, success or failure. So the P, which is equal to 1 minus P, is the probability of failure. So let's get a first of all, this is a binomial distribution. 4 things. First of all, there's what I said, there's a number of events. Right? Number 2, what else? There's a number of successes. Number 3, there's either something happens or it doesn't happen. Either it's success or failure. There's no third option, like you can do this or that. It's like either the event either it rains or it doesn't rain. Sadly, either I don't know. You're playing baseball and you struck someone out, or you're playing cricket and you hit the ball or something like that. Or you played basketball, you got the net, or you didn't get it. In biology, there's sadder things. For example, you have the genetic defect, or you don't. Either you'll learn in physics, either the particle erupts or it doesn't. But there's success and failure. Also, the last thing you need to remember is that the probabilities are fixed. Probabilities are fixed. Now, this is a theoretical idea. For example, let's say you're looking at sports and you're playing volleyball and you serve the net. And it's understood that you have a 90% chance of getting it over the net. But throughout a game, obviously you're going to get more tired. But in this theoretical construct, it always is 20% chance of rain. In our theoretical construct, you always have a 90% chance of hitting the ball over the net. You're never getting tired. So the question is, how do we put this together? Well, it makes. So you might say, okay, well, there's 7 days, and exactly 2, it's rain. So you might say, okay, you know what? So it's 23 over 100, and 23 over 100, that's 2 days. And then you say, okay, well, there's 5 days of what's left over. Well, that's 77 over 100, and maybe I want to substitute this. So you say, oh, you know what, Mr. Arnold, I don't feel like writing it 5 times. And I realize, you know what, you said there's 7 days. So I'm going to say it's 23 over 100 times to the 2 times 77 over 100 to the 5th. Now, you think that's the answer, but it's not the answer. And now we have to go all the way back to the first unit because I don't know which 2 days it happens. So you say, oh, well, I guess I can choose 2 days out of the 7 days. Well, this is the equation for the binomial distribution. So it's 7 choose 2, 20. So it's 7 choose the number of successes to the 2nd power, failures to the 5th power. Now, let's talk about some notation. What's going on here? So, first of all, this distribution, these variables have a distribution of a binomial distribution, and we want to know the number of trials and the probability of success. So, when you immediately see, and they're going to tell you, IB is going to tell you that this is a binomial distribution, the first thing you want to do is write this down. You want to say X, squiggly line, it's binomial. We have 7 trials, and we have a probability of success to be 23%. Okay? That said, now let's move on. Now let's put this together. Let's put this formula together. I'm going to erase this. So the probability that, for example, X equals 2 is equal to, well, we saw there, it was 7 choose 2, 23 over 100 to the 2nd, 77 over 100 to the 5th. Well, let's generalize. The probability that X equals, well, we called it little x, right, the outcome, is equal to N choose X, P to the X, Q to the N minus X. The probability that there's exactly X, that there's exactly X successes is, well, first of all, I'd like to look at this part. Successes to the X, failures to the N minus X. And then we have to, once again, we don't know what days it rained. Maybe it rained on Monday and Thursday. Maybe it rained on Sunday and Friday. We have all those combinations. That's where it comes back to. And that's basically it. Now, you can do all this in the calculator to the point, you can do all this in the calculator. So let's take another one. We can make about you can look at the sheet I gave you. Let's change the problem a little bit. Same thing, same problem. So let's say that X has a distribution of the problem. Let's say it's once again 7, and once again the probability of success is 23%. The next question may be, well, let's look at a notation. So if I write this, the probability that X is less than or equal to 2. How do we read that? What is the question asking us? And we say, okay, well, it looks like what is the probability of rain on at most 2 days? At most 2 days. So what are our possible outcomes? So you say, okay, Mr. Adler, if the probability of at most 2 days, it could be, the X could be 0, 1, and 2. Don't forget the 0. So we were in old school, you have to find the probability X is equal to 0 plus the probability of X is equal to 1 plus the probability that X is equal to 2. This is the probability that would rain at most Tuesdays. What you will discover is that this is clear, the probability of all 7 of these should equal 100%. Now, old school, when I went to high school, I had to figure this out and write these all out and then stick it in the calculator. But now, knowing that this is going to be a part 2 question, I personally would write it out. I'd write, 7 choose 0, 0.23 to the 0, 0.77 to the 7th, plus 7 choose 1, 0.23 to the 1st, 0.77 to the 6th, plus 7 choose 2, 0.23 to the 2nd. Sorry, let me erase that. 0.77 to the 5th, and then go to the GDC. You don't even need to do all this. I mean, it's really all you need to know is this and this. You'll literally be plugging in to the GDC the number of trials, the probability of success, and then this is from the lower bound 0, and then the upper bound is 2, and it will give you all. It'll just give you a probability. So, yeah. What else? What's a little old school thing? Let's say I said, and so the idea is they'll want to see if you understand ideas of probability. So the next thing they will say is, what is the probability that x is greater than 2? And let's say they change the question. Well, it doesn't matter with the calculator. Let's assume, let's just use this. They want to know if x is greater than 2. What does this mean for our problem? Well, we're still in the same problem. We're still on the same vacation. 7 days, 23% chance of rain. The question is, what is the probability it's going to rain more than 2 days? The probability of rain more than 2 days. That's the question. Can you see that? Yeah. So I just told you can stick this in the graphic in the calculator. You're going to say, okay, you know what? The n is 7. The p is 0.23. And then the question is, what is the lower bound of x and the upper bound? Well, the lower bound, once again, if it's greater but not equal to 2, the x is now from 3 up to 7. Now, back in the day, you don't want to put that all in. 3, 4, 5, 6, 7, do all these computations. Is there a faster way? So this is easy with the GDC. The question is, theoretically, is there a faster way? And you might say, oh, you know what, Mr. Adler? We just found that. And so the idea is, if you think about it, here's 0, 1, 2, 3, 4, 5, 6, 7. And we just found this is the probability of 2. And I'm asking you to find this. If it's old school back in the day, you might say, oh, you know what? The probability that x is greater than 2 is equal to 1 minus the probability that x is less than or equal to 2. Visually look at that. The probability of the last 5 is equal to 100% minus the probability of the first 3. So these are, you might see, these are older exercises. And in days when you didn't have a graphing calculator, it's at least, at most, it was a big deal. And this was the connection. But with a GDC, all you need to know is the number of trials, the probability of success, and the probability of success, and the number of successes you want. Maybe this is a part 1 problem, but and so it might not be so difficult to figure out if you're flipping a coin and you're doing 1/2, 1/2, 1/2. That's not a big deal. But it's the 21st century, so it's an important distribution. This is a real life scenario, but the technology takes over the difficult stuff. 3 things, just 3 more things to talk about. First of all, you don't get this formula. You need to, but you can clearly see. I mean, you get it. Yeah, you need to know this formula. I would write it out in the homework and just see that you got the computation. Do not figure this out individually. I had to do that when I was in high school, but use the GDC. 3 things. Oh, I guess 4 things. You don't get the 4 things. First of all, you don't get the formula. You don't get the formula. Second, success isn't always pretty. Sometimes success is like getting a disease. Sometimes success is, not getting somewhere on time. You have to look at the question to see what is success. Success is that you failed the test. What you have to see how they phrase it. So first figure out what is success. Third, this is interesting, the expectation is NP. And fourth, the variance is NPQ. And that's basically it. That's the binomial distribution. In the next class, we're going to be talking about Poisson. It's not an IB anymore, but I'm going to show it to you. Anyway, good luck.